This is where we left off on the previous video. If you have not watched that yet, then you should go back and rewatch it. So this is still 3.1, but it's the second part, so I'm going to call it B if you're looking it up. Now, again, getting practice with this, you should try to get this into slope-intercept form and see what it looks like graphically. So as you distribute, please don't forget that it's -3 that's being distributed, so it's minus 21. So as you look at this, combining like terms, 5x minus 3x is 2x, and -5 minus 21 is -26. So if we were to write this as y equals, and we were to graph this, again, you know how I like to see some labels. So if you're counting by, let's say, -5, -10, 15, 20, 25, you're about starting down here. And you're definitely going up 2 over 1. Up 2 over 1, something like this. Well, if you look at the other equation, let me switch colors, maybe I'll do red. 2x minus 26, oh, well, it has the same starting point and the same slope. So what that means is, as far as the point of intersection goes, is that they share every point. So if my question to you is, what is the point of intersection? That answer is actually everywhere. So every point on the line is a point of intersection. So what does that mean? That actually means that x could be anything, and that's where we get this phrase. Well, I like to write it this way: x is in the element of real numbers, but you might be familiar with an answer from Algebra 2 where they say all reals. That's what it means, that x could be anything. Pick a number for x. I don't know, x equals -7. It seems easy to me because then this piece is equal to 0. So all you have to do is 5 times -8 when you plug in -7 here. So you would get -40. Well, 2 times -7 is -14, minus 26 is -40. Hey, look, the left side equals the right side. That's what it means to be all reals. You might hear me use the phrase infinitely many solutions. That was in a textbook I used to use. I don't remember if this textbook uses that phrase. And you might also see the phrase that this graph is an identity, because the two lines are identical. So I'm going to stop there. I think I've given you enough information. Well, let's look at the next problem. So maybe I'll just go back to black, a boring color, and distribute, just like we did before. So on the right side you have 7x plus 7 minus 5x. Let's see, that becomes plus 10, because remember it's -5 times -2. So as we combine like terms like we did earlier, we get 2x plus 17. So if I went to the graph of that, again, remember I like some sort of labels, and I'll be really lame and just count by tens. 10, 20. So you have 17x, 17, so y-intercept goes up 2 over 1, up 2 over 1. So our graph looks something like this. But then don't forget, you need to graph the other one. Okay, well, where's your starting point? Well, it's down. I'll just put it right here because I'm at the bottom of my screen. At -7. Well, I'll make that 10, sorry. So I'll make this -7, goes up 2 over 1, up 2 over 1. But what you should notice by this graph is that they are parallel to each other. These are parallel lines. So where's my point of intersection? There's no point of intersection. So what does that mean? That means there is no value of x that works. No solution you might prefer that symbol that we've talked about, the empty set, that x cannot be anything. And as far as a good math teacher, they would probably point out that the slopes of the two lines are the same, but the y-intercepts are different. That was your clue. You probably remember that from geometry. That is, the slopes are the same with different y-intercepts. Then they're parallel, and if they're parallel, they never cross. If they never cross, then there's no solution. Other textbooks might use this phrase that I want to share with you, that we call this inconsistent, because it's impossible to find a value for x to work. And you know my test by now, that they're all pretty open-ended. So as long as you write something that clearly states that you know what's going on, you will get full credit. All right. And then here's our last problem that we're solving using the x-intercept method. What the x-intercept method means is that we can find zeros. So what you have to do is set one side, just as a reminder, x-intercepts are called zeros. So set this equation equal to 0 somehow. Well, you can easily do this by subtracting 2x to the left side and adding 1. And what's nice about this problem, so I'm getting the right side to equal 0, is you don't even have to simplify this because I'm asking you to use a graphing calculator anyway. So you can just write it, minus 2x plus 1, and then go to Desmos. And if I ask you to do this on a test, I'm fine if you show the work that shows that you set it equal to 0, and then tell me you went to Desmos or your own graphing calculator to get this answer. So let me pull up Desmos. And I actually have the same settings as the last time, so hit that home screen on the right and you'll go back. And I like to just write as y equals, that helps me out. And I always forget what the values are. 2.5, 2.5, x, I'm struggling here, minus 1, plus 3.4, minus 2x, plus 1. So what's so nice about Desmos is you don't have to hit any more keys. You can just look on what the x-intercept is. And this is why I like to write y equals, because it's saying that if x is negative 3.8, you get y equals 0, which is exactly what we wanted to identify in that problem. And you can check your work by going back up here and plugging in x negative 3.8 for both those x's to get that answer. I'll let you do that. Let me know if something goes wrong. And here's your assignment for this. Notice that it's not very many problems. I think that's because the expectation is that you graph. So, show your work that leads to that answer. Make sure you understand why we use a graph to solve problems.